Alright, so here's part 2 of screencast for Brad Gerber.
Hi, Brad.
Whoa.
Okay, so Daniel had a question. That is so loud. Get your Nutter Butters and throw it away. So loud. Alright, so Daniel had a question about this stuff up here. Whoop, up here. Okay, so a couple things I want to make sure you're clear. This whole smoothness. So if the requirement for finding a length of the curve is that the function has to be a continuous first derivative, and that's what smoothness is literally it's the first derivative you can find. It's differentiable, at least for the first derivative. So a function with a continuous first derivative is smooth, and then you can say its graph is a smooth curve. Alright, so backing up a second, we understood where this came from, this summation. Alright, it's the summation of all the hypotenusae, yeah? Okay, so the issue is, what happens when my step size gets really, really small? Like, because the issue is this sum that we wrote is not a Riemann sum. It doesn't, like a Riemann, like you're taking the
RRAM.
LRAM.
Call it Riemanns. Is this comp sci? Sounds like it.
You didn't know it was Riemann?
That's the way it's called. It RRAM is right hand.
Boy.
Riemanns. Oh, that's the RRAM left right hand
Yes.
Riemann approximation. Okay, so this is RRAM.
So
Where does it
it's
say
not RRAM. So Riemann came up with like all these different, they're named after him, Riemann sums. So the issue is this sigma of square root of delta x squared plus delta y squared, we're trying to approximate the arc of sines here. And so we're trying to go over the entire length, but we have to find the limit as like the dx, right? The delta x, as it gets smaller and smaller and smaller. What's the limit as it approaches 0? Like clearly in our minds we can think that like, oh, it's actually getting closer and closer to the curve, it's gonna be a better and better fit, but yet here it's just it's not like working.
Sine graphs. Yeah.
Well, yeah. So the issue is it's not in a Riemann sum. It doesn't have the form, so we can rewrite it if we multiply and divide each square root by delta k xk. As delta x goes to 0.
As delta x goes to 0.
Yeah, like as our little step sizes get smaller, 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 smaller.
Yeah.
Yeah, so
What about
that's
it?
well, we want to rewrite it that way as like our step sizes go to 0, it will like we can take a limit. Like it has to be approaching something. Okay, so it made more sense in my head than you. Hold on, I'll let you read it. Alright, so check out page 413 for more information. We can go over Riemann sums more. Alright, so let's go over vertical tangents, corner, and cusps. So notice sometimes we have a vertical tangent, just like we do here at 0, x equals 0. We have a corner. Corner is like where you have absolute value, or a cusp. It's like a really sharp point. So where the derivative, right, is undefined at all these points. So we can get through this by, well, using the following example. So first step, we know the derivative is not defined as 0, but graphically there's a vertical tangent at x equals 0. So you guys can see like here, I'm going from negative 8 to 8. That's fine. But instead of using the x coordinates, I could use the y. So you could use y from negative 2 to 2. I can like flip the graph. Oh my gosh, this is not working. Why is this not clicking? Ah. What? What? What are you guys doing? Are you guys okay?
Yeah.
Alright, I'm concerned about them. Alright, so what we can do is instead, since we have vertical tangent where at the origin dy dx doesn't exist, we can change it to x as a function of y, so the tangent at the origin will be horizontal. So that's what I did. I flipped my x and my y's. So it's the same graph, it's just bingo.
How do you do that if there's like a cusp order?
So let's see, here we knew that this equation was y equals 1/3 x, blah blah blah, so I can see down here, so I want to change it in terms of x as a function of y, so since I have y equals x to the third, if I cube each side of y cubed is equal to x.
So doesn't that mean you could just find it in terms of y rather than switching the whole function?
What?
Couldn't you just find it in terms of y rather than switching the whole
What do you mean in terms of y?
What?
What do you mean? Yeah, I was trying to get rid of the vertical tangent.
But like, the vertical tangent wouldn't be an issue if we solved it in terms of y, right?
We are solving it in terms of y. X is a function of y.
So we're finding the inverse function. Do we have to use the inverse function, or can we just use the other variable?
We are using another variable. The original equation was y equals x to the 1/3.
But he's saying, can you use the other variable without having to do the inverse, without having to switch that to the
Right. So instead of the first picture in example 3, couldn't you just use the 2 and 2, and just use the y variables?
No. Well, okay. Wait, I see what you mean. That's what we are doing.
Yeah. Okay, that's what I thought.
That's literally what we're doing.
So we don't have to switch around and find the inverse function every time. We can just use the other variable that doesn't conflict.
Well, when I'm using the -2 and 2, these y coordinates,
Right. You are,
I literally am switching the function.
in a way, yeah.
Yeah, because I don't want to say, okay, y equals x to 1/3, and I say y to the third equals x, and I'm going to use -2 and 2.
Right, so we're just finding it's the x, so we do y, right?
Yeah.
It's a gang, gang. It's a gang, gang.
Do you want me to explain every step, or is it clear what I'm doing? Can you do this on your own? Can you write this down? Can your pencil move on your paper? Cool. So I am going to be using -2 to 2. But the issue is, what equation do I put in there? Like, what's my expression? So I had to put it in terms of y, so I could plug it in here. Okay, one page left.
Was in my last part, I thought maybe I won't do that, so we don't do that.
No.
I'm an idiot, so
Cool.
It gets better.
does it?
No.
No, it's like, it's cool, I love this, but I just can't imagine it getting any harder. Like deriving that, like trying to figure out like that.
Did you do engineering? Like, I know you didn't study as your major, but like.
I did. I was an aerospace engineer major for a year.
Really?
Yeah.
Okay, so like I'm going.
Then I switched to planetary science.
I'm going into mechanical. Am I going to be miserable?
You'll be fine, as long as you're passionate about it.
But like, I don't like math. I don't like doing this kind of math. Like, I like the crap.
Okay.
I like designing stuff.
That's fine. Just know you're going to have to get through some math in college. But remember the whole like partial fractions thing we did? Partial fraction decomposition?
Well,
No, you
the
don't.
guy was like, "Hey, I never used that."
Where he was like, oh, I haven't used this since college and I needed it.
What a silly function.
Yeah, he needed it because he was taking grad classes. He doesn't actually use it in his engineering career.
Yeah, but you use the real hard stuff.
Yeah, I use Fourier transforms all the time.
What?
Um,
But like, as long as you're like applying.
you're getting close. As long as you finish for single variable calculus, learn multivariable, and learn differential equations, and linear algebra, you'll be fine.
But isn't it like all of
No, that's not even close.
classes?
There's a lot more.
I thought like linear algebra and like multivariable is.
Those are like the end of the classes, right?
Yeah.
Those are like freshman classes.
What's after that for college? What's your name?
Well, let's finish this page so Bradley doesn't have to listen to this conversation.
Brad is interested.
Is he?
Hi, Brad.
Is
Hey,
he
Brad.
interested? You're like, hi, Brad, to the wall.
Hello, Bradley. You are now a wall. If Brad comes to school ever again, I'm gonna cry because
Then there'll be two Bradleys.
then there's two Brads and that is not impossible. Wait,
Bradception.
fuck. There's already Bradley Friedland. There's two Bradleys.
That's a girl.
I know.
Oh, it is a girl.
Yeah.
So, this is a silly function.
This is. Look how funny this is.
It's so funny.
Yeah, and it's recorded.
Hi, Brad.
Hi, Brad. It looks like it's how you buy it.
I'll make sure to play this open house, this screencast.
I go up and give my speech, and then they're like, and then they just like play it. It looks like a saggy butt.
Find the length of the curve. Y equals x squared minus 4 absolute value minus x from x to negative 4 to x to the 4th. It is. There's clearly a corner at x equals 0 where neither dy dx nor dx dy exist.
Does that ever happen?
Yeah.
A function like that with just a random.
Yeah.
This entire
The majority of functions we actually use are, majority of the data don't actually fit nice functions, which is why we have like linear regression where we like have a line of best fit, have a polynomial of best fit, and later we're going to use
like that. They but like much worse, but they have like random.
They ever do like loopy loops?
I mean, if you ever see like a spectrograph or when a power function, so
Powerful function.
sometimes on my,
Strong.
so this is like this is wavelength, and then this is like intensity and power. So you just have to like try to minimize noise when I was doing data analysis from astronomy. Okay, what the hell?
Meter.
All right.
I was listening.
Here's my 2 points. I'm trying to go from negative 4 to 4. So what I can do, because this whole corner comes from, Louis, I swear to God. This whole corner comes from the fact that I have a minus absolute value of 4x.
Right.
That's why it's there. Okay, so we know if x is less than 0, let's see, so y is equal to x squared minus 4x minus x. So we can simplify this and say, okay, well, this is the equation. Y squared, wait.
Whoa.
Oh no, it froze! No!
Seizure time.
No!
Dongle time. Brought to you. Imagine having your screen freeze. Brought to you. This meeting is brought to you by Dongle. Okay.
X squared
You see those memes?
plus 3x. Okay, so that's literally what the left half of the graph looks like. The right half is when x is greater than 0. This is similar to what y equals x squared minus 4 times x
Why is it negative
minus,
x though? Why is it negative x though? In the parentheses, y equals x
because
squared.
if x is less than 0, it's negative.
No, it's less than 0. It's negative. No, it would be positive because it's absolute value.
She's saying that's why she's because it's an absolute value is why she's splitting them up into two separate things. And the constant one of them is going to be positive, one of them is going to be negative.
But aren't none of them going to be positive because it's absolute value?
But x inside the absolute value is going to be positive and negative.
So
Right, but it's not going to matter because the absolute value is there.
You have to find the left side of the function. I don't know.
yeah. Because we're trying to, basically I'm writing a piecewise function.
Right.
Like, like if I could write it as x is greater than or equal to 0. Yeah, so basically what I'm trying to do, I wrote it right here. Okay, we are, to find the length of the curve, we write the function as a piecewise function.
Why
So,
are you laughing?
huh?
Why are you laughing?
Because I forgot I had wrote it underneath and I was trying to explain what I was doing. I was like, oh look, I actually left you a place because I was trying to find a place to write it. So it's equal to x squared plus 3x from negative 4 less than equal to x less than 0. Otherwise it's going to be, let's see, x squared minus 5x from, let's see, 0 less than equal to x less than equal to 4.
Okay, I guess my question, how would that ever be positive? How would you get x to the 3x? Because if you plugged in, let's say we plugged in a number less than that, right? Into the regular function, less than 0, so let's say we plugged in negative 1.
Mm-hmm.
The negative 1 inside the absolute value, x, would turn into a positive 1, and then it would just be negative 4.
Yeah.
So how do we say, oh, the thing in the absolute value is going to be a negative since it's outside? Like, I just don't get how that happens.
I see your problem.
Yeah.
So if I leave this as a positive, and I'm subtracting, like since this is a negative x up here, and I'm subtracting a negative x, I would get minus 3x. But that's not what the value should be.
But then the
Should be negative
the
2.
I just don't get it. Actually.
Because we want to write it without the absolute value. Huh?
I don't get why we want to write it without the
Because absolute value is what causes to have a cusp.
Right. But when we get one cusp, it's
Right. Yeah, it should be negative x. This should just be x. So you said you don't understand what part? Why we can put the negative in there?
yeah, I don't get how that
So-
shows us the other side of the function. Yes.
The right side's okay.
So wait,
The right
the
side.
right side makes sense because then it's just positive and you plug it
Yeah.
in and everything's fine and dandy. But like, here's how I would think to write it. If I were writing the left side, I would think, what would I think? I would think it would be, so, negative number. If I plugged in a negative number, then the only thing that would change would be the negative x, because the squared would cancel out the negative and the absolute value would cancel out the negative.
So instead of getting a positive 3x, we get negative 3x.
Yeah.
X squared minus 3x.
Positive 3x. Right? No, I would just think
Instead of having x squared plus 3x, you would want to say x squared minus 3x.
Good. Let me think about that for a second. I'll let you think about that. X squared minus. Yeah, it would come out to x squared minus 3x, I guess. I think. If we're thinking about it my way, which is obviously not right. I just don't get what I'm not getting. Don't get where that comes in.
So we need to have it, so the value I plug in to the bottom part would be the same value I'd plug into the original. So if I put in -1 in for x, I have -1 squared, which is 1,
Squared 1.
minus 4 absolute value of -1, so that's just going to be minus 4. And then minus -1,
Plus 1.
so plus 1. So we need the value to be -2, right?
Wouldn't that just equal -4?
1 minus 4 plus 1. If we're plugging in f of -1,
Yeah.
we have 1 minus 4 plus 1, so that's -2. So what you would want to say is like x squared minus 3x, right?
Yeah.
So if I plug in a -1, I get 1 plus 3, which is 4. That doesn't work out. But if I plug in,
But I don't get why.
don't get y.
It doesn't work out. And why? I mean, like, that's proving that I'm wrong, but it doesn't
Yeah.
show me why I'm not getting it.
Okay, so I'm thinking of like, it's something to do with how to split up an absolute value. Yeah.
I would be able to do this on my own because I never learned how to split up an absolute value.
Oh, okay. That's fine. We can learn. So, okay. So we want to how do I explain this? So when it's okay, so normally when you solve absolute values, you set one equal to positive, one equal to negative. It's algebra 2.
Can we like try doing it with like a function like y equals absolute value of x? Like would that work in that case? Like it's generally easier when I start doing it with like a simple function.
You would split that up into y equals x and y equals -x.
Yeah.
Because inside the absolute value, the x is going to be either positive or negative.
Y equals x, y equals negative x.
Yeah.
That's exactly what we're doing.
Because if you have, okay, check this out. You have the absolute value function. It looks like this. So I have this stupid cusp at x equals 0. So I'm going to split it up and say, okay, well, when x is less than 0, y is going to equal -x. Because you look at the graph and you're like, okay.
Yeah, wow, okay. So yeah, how did that happen?
And then when x is greater than or equal to 0, you have y is equal to x.
Yeah, that makes sense, but how? Okay.
So that's why we put the negative on the left side.
That makes sense, kind of. I mean, like, it's enough for me.
Because then when I plug in, like, back to our -1 example, -1 squared plus 3 times -1, I get 1 plus -3. Well, I get, like, the right answer. Like, it doesn't change the whole
Yeah.
function. It just changes the way we, like, what we call it.
It's enough of an answer.
Okay.
Thank you.
So,
Because you're getting rid of the part where it's actually where the
getting
cusp
rid-
actually is.
right.
So
Well,
then you're- so then
yeah.
it's not a cusp anymore.
Making it piecewise. That way, this one is like this with a hole, and then the other one is like cool, filled in circle and like this. That way, it's still continuous. But I'm, yeah, getting rid of the cusp.
Yeah, yeah.
Okay.
Because the cusp only exists that one because you're removing that. Which is x equals 0.
So let's see. So this is the function, right? So we have, so what would like dx dy dx is 2x plus 3, and then down here dy dx 2x minus 5. Is that okay? Because this is my function, I'm trying to find dy dx, and then I'm going to find dy dx squared, and I'm going to evaluate each length separately and then combine the results. Okay. So, sorry, I wish I could explain it better.
No, you're fine. That was good enough.
Okay. So we're going to go from -4 to 0 of my first function. Let's see, I need to square it. 1 plus 2x plus 3 squared square root dx. Glorious. So gorgeous.
Oh, so then we have to do 2 of that.
And then add the integral from 0 to 4, square root, 1 plus 2x minus 5 squared dx.
Isn't that like some kind of like we have to do flip the integral or something? Or is that you just
We just split it up because we took the integral from -4 to 0, which is defined by this function.
Mm-hmm.
Then we did 0 to 4, which is defined by another function. Added together, we have the total length.
No, I get that. I just was wondering, isn't there like a way that you make it like minus 4 to 0, integral 4 to 0?
Oh, the first one we could do minus and the front, and then go from 0 to -4.
It's not like a thing that you do.
Yeah, you could, this first one, I could put a minus sign out front and then go from 0 to -4.
But like, is that a thing that would be necessary?
No, because this is the number, this is not going to be a nice result, so you could just plug it into your calculator. Because this one is not nice.
Wait, so do we get calculator?
Yeah, so there's some questions, like the one earlier where we had 128 over 32, you could solve that. Okay. Cusps are handled the same way corners are. Split the curve into smooth pieces. Add the length of those pieces. This is hard.
Okay.
All right.
Are we done?
Yeah.
Yeah,
That's
chapter
the
7.
lesson for chapter 7.
So we do this practice test one.
Yeah.
And then Thursday we'll have
We
class.
don't class.
And then
Friday's test.
cool beans.